As you may already know, code is instructions for the computer to do what we want it to do. Typically, each line contains one instruction, but instructions can be arbitrarily complicated. Let's look at three common instruction types. The first of these is what I'll, for the purposes of this video, call idiomatic instructions. These are instructions whose syntax you have to know by heart. In this case, the import command followed by a name specifies that you want to import a package of that name. You can think of this as increasing the number of words that the computer knows. bpy is one of the built-in Blender packages for Python that you can use to modify Blender. The next type of instruction is known as a function call. A function is simply a collection of instructions that are referenced by name. You can recognize a function call when you see a word followed by brackets. Inside the brackets, you put values for the function to use. These are called arguments. In this case, we are calling the print function with a text argument. The print function simply writes its argument on the console. It's very useful for debugging. Some functions also return a value. You can assign these return values to a name, for example, with an assignment. Functions can have multiple arguments. In this case, the order of the arguments determines which argument is used for what. You can also specify what the argument is for with the syntax argument name equals argument. The argument name is determined by the function itself. You need to look at the documentation to see what the correct name is. The third instruction is what's called an assignment. An assignment assigns a value to a name. You can recognize an assignment from the equals sign. Assignments are useful for when you want to reference a value more than once, or to store a value for later use. The value on the right-hand side of an assignment can be many things. It can be a number, it can be text, or it can even be a function call. Whenever you see the syntax word.word, it means that the second word is in the namespace of the first word. For example, one namespace that you're going to use a lot is the bpy.data namespace. This namespace contains a lot of the data in your Blender file, such as the objects and the meshes. You can also keep adding dots to get more specific. For example, bpy.data.objects is a collection that has all the objects in your scene. Let's look at some common data types in Python. Data types are a way to store information for the computer to understand. Numbers are mostly self-explanatory. A Boolean is a data type that is either true or false. It is often used, for example, when you want to execute something conditionally. To input a Boolean, simply type true or false with a capital T and a capital F. To input text, you need to enclose the text in single quotes or double quotes. The list data type is a collection of values. To create a list, you need to type in two square brackets and put in the values that you want inside the list separated by commas. The list can also be empty. To access a specific element of a list, you use the square brackets after the name of the list, and inside you put the index you want to access. The indices of the elements start at 0 and count up one by one. So for example, in my list of text, the index of B is 1. Many data types, including lists, have built-in functions that you can apply to them. These built-in functions are called methods, and you can access them with the dot syntax. Here are some common methods of the list data type. The method index returns the first index that corresponds to an element that is equal to the argument passed to the index method. Be careful, if there is no match, you're going to get an error. The method insert inserts a value into the list. The index of the inserted value is given by the first argument, and the value is given by the second argument. The append method adds another element to the end of the list. The remove method removes the first element of the list that is equal to the argument. Once again, you'll get an error if there is no match. A somewhat similar data type to lists is the dictionary. A dictionary is a collection whose indices do not have to be numbers. For dictionaries, the indices are called keys. To create a dictionary, type two curly brackets. Then inside the curly brackets, type as many key value pairs as you want, separated by a colon, and then separate those with commas. The reason I'm going over this is that some of the return types in Blender scripting are dictionaries. Another important data type in Blender scripting is the vector data type. For example, the positions and the normals of the vertices are stored as vectors. To access the vector data type, you need to import it from the mathutils package. The following syntax from mathutils import star imports everything from the mathutils package. The difference between this and the previous syntax is that with the star syntax you don't need to use the dot notation. You can think of it this way. When you use the star notation, every word you type has an implied mathutils dot in front of it. Don't worry about it too much. So the vector data type is very similar to the list, but it has the limitation that it can only contain floats. To create a vector, type vector with a capital V, then type double brackets, and inside the brackets add the values that you want the vector to contain. The reason that we need two brackets here is that they serve a different purpose. The outer brackets are the brackets from the function call. The inner brackets define a collection that will be converted to a vector. One idiomatic instruction that is really useful to know is the for loop instruction. What a for loop does is it iterates a collection, such as a list, and it does something for every element of the collection. To declare a for loop, you use the following syntax: for iterable in collection colon. The word iterable in the previous declaration is just a name, and it can be any name. At each iteration of the for loop, this variable will contain the current element of the list. Remember that during a for loop, we are iterating the elements one by one. The collection being iterated can also be whatever collection we want. If you want to quickly create a collection that counts up to n, use the range function. Range 10 defines a collection that starts at 0 and counts up one by one up to 10 minus 1, so in this case 9. If you want more control of the range, you can add more arguments. When you call range with two arguments, the first is the starting value and the second is the ending value minus 1. When you call range with three arguments, the first is the starting value, the second is the ending value minus 1, and the third is the step. So in this example, the range would be 4, 6, 8, 10, 12, 14. Let's get back to for loops. There's one more thing I need to tell you. The lines of code that are to be executed inside a for loop are indented. This is how Python knows what code is inside the for loop and what code is not inside. Next, let's take a look at some useful functions. First, we have the numeric operations. When you divide, if you want a decimal output, use a single backslash. If you want an integer output, rounded down, use a double backslash. Equality, inequality, greater than, and less than operations are known as Boolean operations. In Python, they have the following symbols. The Boolean math operations and or are simply achieved with the actual words and or. If you don't know what these do, the AND operation is true only and only if both of the arguments are true. The OR operation is true if either of the arguments is true. If you want to invert the value of a Boolean, i.e. turn it from true to false or vice versa, use the not keyword. One really useful function in Blender scripting is the dir function. When you pass a name to the dir function, it will return all the names that are in that namespace. For example, this is the output when you pass in bpy.data as an input. By the way, you can use this Python console to test out things in your Blender file. It's very useful. The system console, which you'll find in the window tab on the top toolbar, is used to get output from your Python scripts and output from Blender. One final statement I want to introduce you to is the if and else statement. An if statement allows you to execute code conditionally. To declare an if statement, the syntax is if condition colon. The condition can be anything that evaluates to a Boolean, so it can be a function call or it can be a Boolean variable. If the condition is true, the code that is indented just after the if statement is executed. If you have multiple conditions that you want to check, you can use the statement elif. Elif stands for else if. You can chain as many elifs as you want. However, keep in mind that as soon as one condition is true, the rest of the conditions will not be checked. If you would like for all of the conditions to be checked, then instead of writing elif, write if. You can use an else statement to mark code to be executed if all of the conditions fail. This concludes this ultra short introduction to Python scripting. Be aware that in this video I covered only what was absolutely essential to get you started. There are going to be many gaps in your knowledge, and there are many things that I would have liked to have explained more thoroughly, but I couldn't for the sake of time. If you would like me to continue to teach you Python scripting in the future, consider subscribing and consider leaving a comment telling me what I could have done better or what you would like me to cover in the future. In the last section of this video, we're going to take a look at some practical examples. Before I start, I would like to mention that whatever you want to do in Python scripting, the documentation is your friend. The way most people program is by using the documentation. Reading the documentation is how you find out what is possible in the language and how to do it. With that said, let's get started. The goal of this exercise is to make a sign pattern. This may seem stupidly simple, but if you don't know anything about Python scripting, this is quite a difficult challenge. Let's go over the whole script step by step. The first 4 lines just import a bunch of stuff that we need. We need bpy to access our object. We need the math package to have access to the sign function. We need the bmesh package to modify our mesh. And we need mathutils to get access to the vector data type. The next 3 lines expose the data of the object that we're going to be editing. Line 7 assigns the object to a variable. You'll notice that the way we found the object is by referencing the bpy.data.objects collection. Like I mentioned previously, this collection has a reference to all the objects in the scene. The key we're using here, cube, is actually the name of the object in the outliner. Line 8 selects the object in case it wasn't already selected. Line 9 references the data of the object. The next 3 lines create a bmesh representation. This is a special data type that allows us to edit our mesh. Line 12 creates a new bmesh object called bm. Line 13 initializes the bmesh object based on the data of our object. And line 14 is a bookkeeping function call. Whenever you want to directly reference the vertices, faces, or edges of a bmesh object, before you do, you need to call this function. Line 16 merges all the points of the default cube to a single point. You might be wondering how I found this function, but in your heart you should already know the answer, by reading the documentation of course. The first argument of this function is the bmesh object that we're working on, the second is the vertices that we want to merge, and the third is the location that we want to merge to. Lines 19 to 21 define parameters for the sign. dx is going to be the difference in x between consecutive points. The amplitude is going to be the amplitude of the sine wave. Line 22 defines a collection that will contain all the vertices that are going to be extruded at each step. The way we're going to create the sign pattern is that we're going to extrude the vertex that we just created by merging all the vertices again and again. Notice that even though we're only going to be extruding one vertex, we're still creating a list. This is because the extrude function expects a list as input. It doesn't matter that there's only one vertex in it. Line 24 defines a for loop of 100 iterations. That means the code inside the for loop will be executed 100 times. On line 25, we're extruding the vertices defined by vs. Notice that we're assigning the return value to a variable called ret. If you read the documentation for this function extrude vertices individual, which we're using right here, you'll see that the return value for this function is a dictionary. This dictionary contains the edges and the vertices that were just extruded. On line 26, we update the vertices that are going to be extruded in the next iteration. We do this by replacing them with the vertices that we got from the return value. On lines 27 and 28, we set the coordinates of this newly extruded vertex. The location of a vertex is stored in a variable called co. You can access the components of a vector by typing .x.y.z or by simply using the bracket notation. On line 29, we increment the x value. By the time we get to line 31, the for loop has finished. This function called to extrude edge only extrudes all the edges of our mesh. Incidentally, the return type for this function is a dictionary again. It has a single key value pair that contains all the vertices, faces, and edges that were just extruded. The idea is that we want to extrude our sign pattern, which was in the xy plane, in the z direction. Line 33 is what's called a list comprehension. It's something I didn't cover in my previous explanations. A list comprehension is a way to create a new list by iterating over another list. The first expression that appears in a list comprehension is what's actually going to create the new list. In this case, we're saying that the new list is going to be the same as the old list. You'll notice that the second part of the list comprehension resembles a for loop. This part defines the source collection. Finally, optionally, you can add an if statement at the end. If an if statement is present, then only elements of the list for which the if statement is true are included in the new list. In this case, the if statement is simply checking if V is of a vertex data type. So ultimately, what this list comprehension is doing is that it's returning the vertices that we got from the bmesh.ops.extrudeEdgeOnly function. I hope I didn't confuse you too much. Line 34 simply translates the vertices that were extruded upwards. Line 35 actually applies the transformations that we did to our bmesh object to our Blender mesh. Up until this point, all the transformations were not quote-unquote real. They weren't actually applied to our mesh. Finally, line 36 frees the memory that was used by our bmesh object. The documentation recommends that you call this function whenever you're done with your bmesh object. And that's it. I tried to pick an example that was not too trivial, but also wasn't too tough. I hope I succeeded, but I think this might have been a little bit too difficult for a completely beginner audience. Let me know in the comments what kind of topic you would like me to cover in the next Blender scripting tutorial. And with that, I'll see you next time.